on. Okay, so looking at these, what's going to happen for number 1 here? Oops, let's lock that in. What's going to happen with my square and my square root? We're not going to separate them because there's adding and subtracting inside. What happens with this square root and the square? What undoes the square root? A square. 3x minus 1. Ta-da! The square undoes the square root. It cancels out that root, and we're left with just that radicand, the bit underneath. How about for number 2? What happens there? They cancel out. My cube cancels out my cube root. It undoes it. Those are inverse operations, bringing that word back. 2x plus 5 is what we have left over. At this point, we can't do anything else with it yet. But that's what we're doing with there, okay? Boop. All right. That's all it is for DeVoeWorks. So turn that page in when you're done. We're going to go to page 334/335. As I recall, it's awkwardly over a page turn. I'm going to grab my book so I can see. If I put both page numbers like that, it usually means I've snipped it from 2 different physical pages. This looks like 1 page, but I guess it's not. Now you're perilously close to the end of this workbook. Oh, snap. 334. Got it. All right, yeah. It is awkwardly split across 2 pages because that's totally good book plan. So what we're going to do is we are going to do adding and subtracting. Yesterday, you guys did some multiplying and some dividing with radicals, where we split them apart and combine things together and simplify. When we're doing adding and subtracting of radicals, we're going to simplify as much as we can, and then we can add or subtract like radical expressions. Meaning, we're going to simplify, simplify, simplify. So, for example, they're looking here at square root of 18 and square root of 32. They're going to birthday cake both of these as far as they can. 18 becomes this 3 square root of 2, and 32 becomes 4 square root of 2. So I'm going to show. So if we did square root of 18 plus square root of 32, what we're really saying is, I am running out of space here. This is the same thing as 3 square root of 2 plus 2. No, not 2. What was it, 4? 4 square root of 2. That is really close to the edge, but that's okay. They mean the same thing. We just wrote it like this. And the way we treat it is that since this is the square root of 2 and this is the square root of 2, this is the same thing as 3 somethings plus 4 somethings. What is 3 somethings plus 4 somethings? 7 somethings, right? 7 somethings. But here, something is not just a something. I know what it is. It's 7 square roots of 2. So what we do is we're looking at the numbers out in front. I can add or subtract the numbers out in front, but only if the guys under the radical match. That is what this hot mess down here is trying to tell you. Adding and subtracting radicals just means we get to the same radicand, and then we can add and subtract the coefficients. It looks like a hot mess of crazy, but I promise it's not the worst. But this bottom line is I think the worst. The bottom line is the worst. It's, yeah, the worst. Boop. So we're going to look at this. Example 3. They do it the weird way the book does. We're going to get to the same sets of pieces, but I'm going to do it the way we're a little bit more familiar with. So we've got 6 square root of 45x plus 12, square root of 12, minus 3 square root of 20x, because why would we start with simple stuff? Good gravy. So I'm going to simplify this thing first. My square root of 45x. What this means is we're going to birthday cake that 45. What's a prime number I can take out of 45? 5. It's going to leave me with 9. What's a prime number I can take out of 9? 3. It's a prime number I can take out of 3. 3, and that leaves me with 1. So the square root of 45, how can I write this in a simplified radical form? What's going to go on the outside? 3, because I have a pair of 3s. That goes outside. Left inside the house, we have 5, because he does not have a buddy. And that x is still there. So square root of 45x, and they have it down this line is where we're going to put our simplifieds. 3 and 5x. Holy chunky pen, Batman. Why does that feel so big today? Even zoomed in. There we go. That's better. So 3 square root of 5x. I want us to practice doing it, so we're going to do the 12 as well. We're going to get our square root of 12. We're going to birthday cake 12. What's a prime number I can take out of 12? Prime. 4 does come out, but it's not prime. 2. Divide 12 by 2 and we get 6. What's a prime number I can take out of 6? 2. Leaves me with 3. What's a prime number I can take out of 3? 3. So when we write 12 in our simplified radical form, what goes outside the house? 2. There's a 2 over here. I have a pair of 2s. They go outside. And inside the house, we have our doesn't have anybody friends, 3. Which is exactly what they have right here. I just wanted us to practice it, doing it into our simplified radical form. And then we have one more of these. We're going to do this 20x. So let's take our 20 and birthday cake it. What's a prime number I can take out of 20? 2. Leaves me with 10. What's a prime number I can take out of 10? 2. Leaves me with 5. What's a prime number I can take out of 5? 5. Boop. So when we put this in our simplified radical form, what goes outside?
2.
A 2, because I have a pair of 2s here. And what goes inside? 5. And in fact, since it's 20x, it's going to be 5 what? $5x. That x stays inside because I don't have a pair of x's. So on this line here, we're going to have our 2 square root of 5x. The way the book does it is a fine way to do it, but that is not the way that we have been simplifying radicals for the last 4 years. So you can do whichever works better for you. If you like the way the book does it, great. If you like to do a birthday cake, great. Do not try and type square root of 20x into your calculator. It doesn't know how to do variables in these kind of simplifying things. So then what we're going to do is we're going to see that this wasn't just, whoops, that was not the laser pointer, the square root of 45x. This was 6 times the square root of 45x. So this piece that we had down here, we still have a 6 outside of it. So what we're going to need to do is we're going to need to multiply the 6, just so we have that color back, in but just to the 3. We don't need to multiply it through. We're not distributing it through the radical. We're just multiplying that 6 times the 3. So what is 6 times 3? 18. You did plus. 6 times 3. Over here on our 20, we also had a 3 out front up there. So we have to multiply this here to get rid of these parentheses. So we have 3 times 2. Yeah, that's going to be our 6. And now we're looking to do our adding and subtracting. I have 18 square root of 5x plus 2 square root of 3 minus 6 square root of 5x. Can I add all the things together? No. They need to have the same radicand. So which things can we work with? 1, 2, or 3? 1 and 3 have the same radicand, the bit underneath. So when we look at those, what do we have? I have 18 square root of 5x minus 6 square root of 5x. What is 18 square root of 5x minus 6 square root of 5x? 12 square root of 5x. Okay? So if it helps you to do that where we kind of mumble the radical, that is a fine strategy to do it. It's 18 minus 6 18 somethings minus 6 somethings. 18 square root of 5x minus 6 square root of 5x. And that's as far as it'll simplify. I can't go further than this. This is our answer right here. It's really annoying that they did a really complicated one as our example number 1. They make the worst choices. What questions on this one? Okay. Because then they go straight into the other thing. Like, what? Which is really funny because we've already kind of like done some of this when we were working with our simplifying stuff yesterday. But we're going to look at multiplying radicals. It's the same exact process that we did yesterday. Again, they do things really weirdly. And I know there's not a ton of space in the book. There is a little bit on the bottom right of this where you can do this. Because I do this, the first step is actually the same. Where I take the what's in fronts and I put them in front. 4 times 3. And then we take the what's inside and the what's inside and we put them next to each other. And we multiply those together. This is when I split off. Because I like to get all my things next to each other. So I'm going to bring this over here. You guys do have a little space to the bottom right. And I'm going to say, all right, 4 times 3, that I can do. That's going to be 12. And then I'm going to have my square root. I'm going to give myself a little bit more space here, just because I'm going to need it for right now. Cool. And I'm going to take and line everything up, grouping them together. I'm going to have negative 10 times 16. And I'm just rearranging what order they're in. Then I'm going to put my x's by each other. X squared. Oops, I needed the color there. So that's x squared from my green function times x to the 4th from my purple. Then I'm going to put my y's. Y to the 6th times y, ooh, that's purple. Y to the 4th. It's all the same pieces, I just changed their order. Then we're going to simplify this. So I'm going to do my numbers, my x's, and my y's. My 12 is still hanging out outside. Square root. What is 10 times negative 10 times 16? Negative 160. 10 times negative 16. It's all being multiplied. What is x squared times x to the fourth? X to the what? 6. Y to the 6 times y to the fourth? 10. Sorry, I couldn't hear you. I couldn't tell quite what that was. So if I don't know, I just stare at you blankly until we clarify. So there it's significantly simplified. But I see a whole lot of even numbers in a square root. We're going to see if we can take it even further. So this is when we're doing the exact same pieces we did yesterday, where we break it apart. So my 12 is still hanging out front. I'm going to do the square root of negative 160, square root of x to the 6th, and square root of y to the 10th. And you guys can go in whatever order you guys want to. Whatever order makes sense for your brain, use that. I'm going to fix that 6. Whoa, that was a highlighter, not a pen. That still doesn't look like a 6. Better-ish? I don't know. I can't make that 6 look right. Anyway, we're going to take all these pieces and we're going to simplify them. So 12 just coming down. He's just hanging out. What are we going to do for this negative 160? How can I simplify this? Birthday cake. Let's do it. I'm going to do it off to the side over here. What's a prime number that comes out of 160? 10's not prime, though. I mean, you could, but you then have to split it into 5 and 2. Let's do 2. Gets us down to 80. 2 gets us down to 40. Another one. 2 gets us down to 20. Gets another one. 2 gets us down to 10. Give me a couple more. 2 left with 5 gives us 5. Boop. So then we're in square root, so we're needing pairs. I have a pair of 2's and another pair of 2's. So what is going to go outside the house? I was going to say I have 2 times 2, which means we have 4. What goes inside the house? Everything's multiplied here. 10. What did we forget about? Negative. Which means what do we put down here? What do we do when we have a square root of a negative? I. So all these pieces are being multiplied together. So we have 12 times 4i square root of 10. Let's do square root of x to the 6. What does that give us? X to the what? It is to the 3rd. If it helps, you guys can go 1, 2, 3, 4, 5, 6. That's x to the 6th birthday caked. And I have 1, 2, 3 pairs of x's. How many pairs can we make? And then we're going to do boop, y to the 10th. What is the square root of y to the 10th? Or how many pairs of y's can I make from 10y's? What? This is fifth root. I'm doing this in square roots. Oh my, that's okay. We're getting a different answer than the book because I'm 100% lost track of that. That's okay. We're square rooting now. Go team. I totally lost track of the fact that we were doing fifth root. I'm like, we're not getting the same answer, but that's okay. We're gonna rock it. We're doing awesome. We're doing it right. We're doing a fantastic job. Go team. We changed the question. So we have 12 times 4, which is what? 48. And then I'm going to put my letters, x cubed, y to the 5th, I, square root of 10. So we did the same process up here. I just 100% did not see the fact that those were fifth roots. So we changed it. We still did the process. We did the important part. Just watch out for different roots. I don't think I assigned you any that were like crazy high roots like that, because those are, I don't have the question number circled, so I can't help you with that. Because those are honestly not super common. They're not. They're just not. Fifth roots are one of those things that is more theoretical than something that's practical. Mostly what we're going to use, and most of what you'll see on the review, is things like square roots and cube roots. Those are really realistically real-worldy, the things we're going to use most. Okay? I hate this. I encourage you to look at this one. We are not going to wind up doing areas with radicals. Gross. But what they are doing is they are practicing their multiplying the radicals together. And then once they simplify, which I can give you these answers. We can't even, why did they do this? Because then we can't even add things together. This is not, no, yeah. We're going to just say, oh, look, they multiplied their radicals together, and then they went crazy pants on their simplifying. So they multiplied their radicals together. They multiplied, here they just could only multiply their coefficients. And here they could only multiply coefficients. So they did 3 times 7 to get 21, and 8 times 8 to get 8 squared. They did the multiplying our coefficients, 3 times 6 to get 18, and 8 times 3 to get 24. So multiply the things outside, multiply the things inside. We're ignoring the rest of the area problem involving radicals because gross. The book made a choice, and I don't like it. I thought it was going to have simplifying in it, but honestly, I didn't look that close. It's gross, and I hate it. And that's all we're doing. So if you guys have questions on stuff, like I know 6-4's homework has been kind of kicking some booty because the book didn't do things super great and then expected you to do those questions without having actually done a graph. So if you have questions, now is an excellent time to work on that. So let me do a quick spot check and make sure I didn't do any crazy giant roots like that. The only time you see a fifth root in the homework is a simplifying of the fraction thing like you guys did yesterday. So none of the multiplying them together where we have to pay attention to that because that's the worst. Okay, all of the ones where you're multiplying two radicals together are square roots like I accidentally did today. Okay, so we have a solid 10 minutes plus. Not quite 15, but 10 minutes plus until announcements. work on stuff, ask questions. I know the past couple of days we've wound up right to the bell because of there's just so much stuff to cover. And the book, again, made some strange choices when it came to bell work. It was a choice. So use this time, ask questions. If you are one of those people that likes to start on the study guide on the weekend, the study guides are up. They're up in the hanging file over there by the turn-in bin. I already have the answer keys posted on Canvas. I also have a physical copy over there on the board. The study guide is your review. We will have time to work it together. We will have time to answer questions or ask questions together. We still have 2 more days of notes. So if there's things on there you haven't seen yet, you're right, because we haven't seen them yet. We'll do those Monday and Tuesday. But I like to try and get you guys the study guides the weekend before the test, just in case we're one of those people that has classes and rehearsals and sports and things all throughout the week and work. Okay, so as you're working on stuff, let us know if you have questions. We're happy to help. Rock on. Happy Friday.